Hi, my name is Deepesh. Welcome to my channel. This is my first YouTube video, hoping to publish more in coming months. Recently, I had the opportunity of speaking at AWS Summit India 2022 on running multi-arc containers in EKS along with Ashwin from Amazon. Prior to that, I was speaking at AWS Dev Cloud Alliance meetup on the same subject. My content on both these events was mostly a presentation. Post these sessions, I was getting a lot of queries from attendees requesting for samples or code snippets. If you wish to go through the AWS Summit session, you can click on the link in the description box. To address these queries, I ended up building a separate setup on my personal AWS subscription. In this session, we will experience building and running multi-arc containers in an EKS cluster. For this, I have written a small microservice in Java using Spring Boot. Quite simply, when we call this service, it reads system properties indicating CPU architecture of the operating system where it is running and returns pre-formatted HTML. In this session, we will build a multi-arc container image using Docker with buildx. Once the container image is built, we will push that container image to Docker Hub. Post that, we will run this multi-arc container in EKS cluster. Our expectation is x86 container should run on worker nodes powered by x86 CPU architecture, and likewise ARM64 containers should get scheduled to run on worker nodes powered by ARM64 architecture. In our case, ARM64 nodes are running on Graviton processors. Now let's look at prerequisites. We will need a Docker Hub account to store our container images. In this demo, I am using public repository, but that's not advisable for enterprise or production use cases. We will need AWS account to host EKS cluster, and within that we will need to have a VPC. A EKS cluster will be required. This cluster should have two node groups. One node group will provision ARM64 worker nodes, and the second node group will provision x86 worker nodes. On the dev box or Linux terminal, whichever you prefer to use, you should have Docker along with buildx. kubectl should also be installed, and kubeconfig should point to EKS cluster that we will be using. And in addition to that, any code editor like Visual Studio Code should do. So let's get started. Now let's have a quick walkthrough of our EKS cluster. So I have used EKS Cuttle tool to create the cluster. The cluster name is defined here. Then this is the region where it is located, and these are the subnets. Now the important point to note here is we have two node groups. The first node group is for running x86. To run x86, we are using instance type as T2 micro. And the second node group is to run ARM64 based nodes, and for ARM64 we are using instance type as T4G small, which is Graviton processor based image. If you look here in the console, so this is where the cluster has been created. It is running version 1.22. These are the two subnets that we had defined in our script. And if we quickly query our cluster, so these are the two nodes that we have provisioned. Let us see what are these nodes in console. So these are the two nodes that have been provisioned. So one is T2 micro, second is T4G small. These are part of the EKS cluster. Now as you could notice, this particular one, the second one highlighted here, this is the one with ARM64, and the first one is x86 or x64. The second important file that we have here is the Docker file, and within this Docker file we are taking architecture as the argument from command line, and based on that we are going to pull our base container image from Docker Hub. So this is important point. And the other thing is this particular jar file, this is the application that we have built using Java Spring Boot. And what it does is it simply when we call this, it simply returns the underlying operating system parameters. So let's just create our container image. To create the container image, this is the command that we will be using. So notice that we are passing hyphen hyphen platform Linux slash ARM v7 ARM 64 and AMD 64 as parameters. Before we run this command, let us quickly switch over to our Docker Hub repository. We'll refresh this and see what is the last container image that we created. Okay, so the last one is v05. Okay, so now we will change this to v06, so that is the next version. All right, so this is built. We refresh it. Now we see v06 is appearing here. We click on this and let's see. So notice this operating system and architecture. So the parameter what we had given, it has created a multi-arc container image that will support ARM v7, ARM 64 and AMD 64. AMD 64 is our x86 image. So this is how we have created our multi-arc container image. Next we will run this in our EKS cluster. As the next step, we are going to deploy our multi-arc container in our EKS cluster. So before we do that, let me just give you a quick sense of what all is already running in the cluster. Okay, I have this deployment which is not required at the moment, so I'll remove this. We'll redeploy this. Okay, now I'm also running Nginx ingress controller. So you see here we have a load balancer that is provisioned. If we switch over to AWS console, here you see this is the load balancer. So what we are going to do is we will deploy our multi-arc container in the cluster. Right now if I hit this load balancer, it is going to give 404, Now what we will do is we will deploy our application and then hit this load balancer and see what we get. So we had created three replicas of our pod. So two of them are running on this particular node with the IP address ending with 167, and one of them is running on worker node with IP address ending with 196. Let us see what these two are. So ending with 196, this is a x86 node, and ending with 167, this is a ARM64 based node. So now let us go to our load balancer. We will hit it. So if you notice this particular request has been processed by uh, ARM64 based processor. Now we will reload. Ah, okay, in between we saw AMD 64. This is x64 based node. ARM x64. What is happening here is we have two worker nodes. The first worker node is running ARM64 based operating system, or rather it is running on ARM64 CPU. The second worker node is running x86 based CPU, thus operating system. So when these pods are getting scheduled in either one of them, the underlying runtime knows that what kind of CPU architecture is supported on that OS, and accordingly it pulls appropriate container image from Docker Hub and it runs that compatible container image in that OS. So that's all for now. Thank you.